But where did he go?
So I told you he met up with an American.
Yeah.
And yeah, he was talking about it because this one kid is Austin.
Oh, so he was ready to go.
Yeah, well, there were pictures of him. Well, hey, you know, we did just. I have pictures of. Well, you did. Yeah. And then it was all being
I can
yesterday.
take minutes.
Okay.
I will try to get somebody else over. We are gonna start. Hello? Yeah, we're gonna start in a few minutes. So before, is anybody willing to take notes? We have Alex, thanks, and if we will appreciate to have one more people because Alex is presenting. It doesn't take that much effort. So anybody willing to help Alex with the notes? Okay, thank you.
Supposed to start 5 minutes ago.
Yeah. So,
Okay, let's go ahead and get started. So we want to remind you about intellectual property. If you have intellectual property associated with your draft, you need to say so. Actually, we should update the RFC number here. It's now 8179. The note well is here. This is the updated one. It does reference 8179 here. Blue sheets have been started. Carlos tells me that while I was out of the room, he twisted arms for note takers and jabber scribes. Okay, so we're good.
So we have minute takers, but we don't have a jabber scribe.
No, we do not have a jabber scribe. Any volunteers? Come on, it's easy. Please. I guess we're going to proceed with that one. Can somebody watch the jabber room, and if somebody wants something said, thank you. The agenda. So we're going to start with the work item. That is our big standards track deliverable. And then we're going to move to our two informational documents. Any agenda bashes? Okay, we
I just opened it and the jabber isn't offline.
Oh, no. Can you check that? She says the jabber room's offline. Okay, so we had a goal of being in working group last call with the 802.11 OCB support with IPv6. We did not quite make that. So our goal is to get there shortly after this meeting. To that end, we're hoping to be in working group last call by the end of September. So we've asked Alex to drive the discussion towards closing those issues. Okay, and then we'll move the focus to the informational documents where we'll be asking for volunteers to review so we can wrap those up as well. Any questions? Okay. All right, Alex. In the box. We couldn't get the little clicker to work, so you'll have to say next slide. Doesn't work.
Doesn't work. Okay. So.
Yes. Okay, I hope people can hear me. Yeah, I have this screen. I will look down from time to time. The presentation is advancement of our internet draft, which is transmission of IPv6 packets over IEEE 802.11 networks in mode outside the context of a basic service set. the slot is relatively brief because there are not many issues. You will see the issues from, next slide please, the issues from some minor textual issues that took the most time to fix, and then some issues that were discussed around Chicago meeting, and one issue that is still on the table on the last slide. Next slide, please. Yeah, so I believe it's very small for people at the end of the room. The slides are also on the IETF website in the proceedings. You could download them, and this is a suggestion about the old text saying that IPv6 works over 802.11 OCB in the same manner as over 802.11 Wi-Fi. Whereas, well, the commenter says it is not true, and there are some exceptions in OCB. As such, this new proposal is that IPv6 works over 802.11 OCB in the same manner as Wi-Fi with a few particular exceptions. So, minor clarification. Now, in the second half of the slide, there is this RSU term discussion. I'd like to start by saying that we have this definition of RSU, roadside unit, in this draft because we discussed a lot about what is an RSU and how it works, but we discussed it in a particular context, which was the handover between one RSU to another RSU, or in the context of RSU advertising some information to the cars that pass by. At the same time, in this draft, we extracted all the handover discussion and all the POI discussion, and all these things are outside of these drafts, but we still kept this RSU definition here. And if you look at it, you'll see that RSU is defined, but it is not used throughout the document. So current definition is RSU is a computer equipped with at least one IEEE 802.11 interface operated in OCB mode. This definition applies to this document, and an RSU may be connected to the internet, may be equipped with additional wired or wireless network interfaces that run IP, and an RSU may be an IP router. Okay, this is as a result of a comment we had that said that in some particular context, the RSUs are not routers at all, and they really want it disconnected from the internet for some security reason. So at this time, this is our new definition that is in the draft. Next slide, please. On slide 4, this is about, the first half of the slide is about how we talk about these 802.11 specifications. It's more proper to talk about them as IEEE specifications, and also to add this TM acronym between parentheses. So right now we say IEEE STD 802.11p TM-2010. You'll see more in the last slide about this. Another correction that was suggested was about this notation of FF:FF and so on. It was suggested that the base 16 numerical notation is 0x and then many Fs instead of FF:FF. So at some place we use this 0x notation of a hexadecimal number. Next slide, please. This again has raised a few comments from a few people about the prohibition of IPv6 on some channels. And after several comments back and forth, we came up with this proposal down of the bottom half of the slide, which says that prohibition of IPv6 on some channels is on. There are some channels that are reserved for safety communications, and IPv6 packets should not be sent on these channels. At the time of writing, the prohibition is explicit at higher layer protocols that provide services to the application. These higher layer protocols are specified in IEEE 1609 documents. And that national or regional specifications and regulations specify the use of different channels. And these regulations must be followed. That's our new text about the prohibition of IPv6. Yep, next slide, please. There was a misunderstanding about interface, the word interface. To ISO people and to IEEE, an interface may signify interface between layers, but in the text that we wrote here, is interface means a network interface, like an interface card. So this text clarifies this. And then in the bottom half, there is a discussion about using multiple such interfaces in a vehicle. And some vehicles may use one interface that is dedicated for non-IP communication, but still 802.11 OCB communications. So the comment was that this is not a must, and that whereas some vehicles may have several OCB interfaces, it is not necessarily a must that one of them should be completely allocated to non-IP communications. As such, the new text is the following. There are considerations for 2 or more OCB interface cards per vehicle. For each vehicle taking part in road traffic, one OCB interface could be fully allocated for non-IP safety critical communication. Any other OCB may be used for other types of traffic. So that's the resolution of this multiple interfaces issue. Next slide, please. In Chicago, we discussed a few, we agreed on a few points that are listed here. We removed the text about mobile IPv6, NEMO, V6, and multiple care of address, but we kept this multiple interfaces aspect. We clarified that the beacon is actually an IEEE 802.11 frame beacon. We clarified the figure that shows infrastructure mode and OCB mode side by side. Added a reference to the IP security RFC. Added a section address mapping unicast that I will show next. Added the .11 trailer to pictures of .11 frames. And added some text about snap carrying the ether type. Next slide, please. This is the section we added that is the address mapping unicast. It is practically a copy-paste from RFC 2464. And except that the Ethernet address down the slide there is the text about this Ethernet address is much reduced. Okay, we just said that the 48-bit Ethernet IEEE 802 address is in canonical bit order. That is all that we kept, following agreement we had in the Chicago discussion. And next slide, please. There is one issue still on the table. We make reference to a number of standards outside IETF in this draft. And since we started this effort, many of these documents have evolved. Especially, we received an explicit request from Michel and from IEEE that we should mention these standards in their most recent format. As you see, the 802.11 TM is now 2016 version, 1609.2 TM 2016, and so forth. We need to add this in the draft at this time. That's a specific request from IEEE. Yeah.
Okay. Yes, and it works. Also, I think we should revise all the informational references to make sure that they are up to date.
Michel, your name.
Michel Wetterwald, FB Consulting. Okay. Yeah, we have discussed it in parallel with the last ETSI meeting, and we think you should revise all the references and make sure that they are up to date.
Yes, especially the ETSI references. If you can
ETSI
help
and
me.
especially IEEE.
Yeah. So, yeah, 10 minutes. Okay, so I think I still have 1 or 2 minutes. I wanted to say that this draft is very important, and it is a basis for many prototypes or trials on which some people are involved. But I think we need more reviewing of this. And I would like to try to think whether who would like actually to help with reviewing the document and give a external view of this, or and help make improvements of the draft. Okay, even though it has been reviewed by some commenters in the past, but right now we need more reviewers to help improving the document. Yeah. There is, okay, Sri may review it. I also asked, I don't know whether Tom Herbert is in the room. No, okay, but I would like to have a few reviews on this.
In addition, the working group last call.
Sandra Cespedes.
Okay.
Yeah.
And we're targeting end of September for the working group last call, so let's get those reviews and proceed to that route.
Yeah.
Your last slide.
Yep. Okay.
Hello, everyone. My name is Paul Jung from Sungkyunkwan University in Korea. So the survey on IP-based vehicular networking for ITS. This work is Korsor, Sandra, Nabil, Jerome, and Michelle. Next slide. Recently, this document adopted as our IPWAVE working group document from the version 2 individual working, the individual draft. So the mailing list, IPWAVE, Alex, and other people, Carlos asked, including the use cases. So that's why our authors are working for use cases for V2I and V2V networking. Next slide, please. The objective of this draft is to survey the activity of academia, standards developing organizations, and the industry of IP-based vehicular networking for intelligent transportation systems with use cases. We assume for vehicular networks, as main link types, we consider IEEE L2.11 series such as AB, GN, OCB mode, and also cellular links, 3G, 4G, 5G new radio. Also, IP version 6 we considered as the main network layer, and also rotor sign unit, Alex also clearly defined. And the traffic control center is a central node for managing vehicular networks, such as local management for the vehicles. Next slide, please. This is the list of the topic for vehicular networking: address, IP address auto configuration, vehicular network architecture, network routing, and the management mobility management, and also the vehicular network security, and also standardization activities for vehicular networks. Also, this time we included the use cases for the vehicular networking. Next slide, please. The use cases, first category is for V2I networking. So you can see navigation system intersection management, which means the vehicles passing through the intersection without without waiting for the traffic light. In the picture, self-driving environment case, vehicle communicate with the RCU assigned schedule information, such as which lane, which time, which lane goes through which direction. So this paper explained that kind of thing. And the emergency network system, the first responder network authority is already provided in the United States for emergency service. So, and also the next one is pedestrian protection system. Nowadays, many people carrying smartphone, looking at smartphone, working, eating, something like that. So we can protect the pedestrian using V2I communication. Next slide, please. The second category is vehicular networking for V2V. The first one is driving safety system, such as we can say context-aware navigator, which means right now our navigator doesn't have any context, which means there is no neighbor vehicle, neighbor pedestrian. In the future, the vehicle or pedestrian can communicate to each other, and they can aware of each other, and then we can avoid accident. Second category is automated driving systems for cooperative adaptive cruise control and also automated truck flattening. Those are implemented by UC Berkeley past project. And third one is a vehicle-to-vehicle running system. In Coyote, this is a French service, which means the speed limit information, also traffic hazard information shared by the social networking over GPRS with IP networking. Secondly, in the United States, Waze, TomTom, Live services can use for the community for the vehicular network. Next slide, please. Actually, the contents of this survey draft, I put the content summary in the appendix, so audience can refer to the detailed information appendix. But right now, I just kick a summary. So this also I presented last the IETF meeting. So we discussed the suitability of IP version 6 over WAVE, and also we needed to adapt neighbor discovery protocol for fast-moving the vehicle environment. Next slide. Also, the IP version 6 link concept case, remember the vehicles construct mobile or vehicular add-on network. So the link concept is different from traditional legacy IP version 6 link. So we needed to support link using the ND neighbor discovery proxy or the VANET mobile vehicular add-on network routing. And also to facilitate address configuration, we can using neighbor discovery or DHCP. Next slide, please. Also, the vehicular network case, if we are using V2I communication, we consider traffic control center or traffic management center having the trajectory information, because in the future, many vehicles are learning the navigation system, especially the self-driving environment case. The vehicles are robots, right? So they are moving according to navigation system. They share their moving trajectory. So we can take advantage of the trajectory information for V2I networking, such as a handover or something like that. Next slide, please. The next steps, we try to include more paper and also use cases and industry activities, such as automotive companies. Nowadays, GM, BMW, Toyota, Honda, Hyundai, they are working for the automotive company for self-driving. And also the Car2Car European Project Consortium. Also recently the 5G Automotive Association, European Automotive Telecom Alliance are established for automated the driving environment. And also we can refer to the use cases already developed by the ETSI, European Standardization Body. So they having this HGTR, this number, providing the basic set of use cases. We can refer to that. And also we can include the taxonomy table, summarize each technical the topic. So each technical section will have a taxonomy table, categorize the technology according to protocols and schemes for the easiness for the audience. Our plan is, according to the milestone, our working group, we try to working group last call request next Singapore meeting. So please review our draft and then give me your feedback. Welcome your comments. Thank you. Any comments?
Yeah, Carlos Bernardo, I have one question on the section that you have on the IPv6 link.
Mm-hmm.
I wonder if we need to have that section, or you need to sync with Alex, because at the end of the day, that is basically the main deliverable of the working group is on this. So I wonder we need to have that there, or not, because we will have the solution specified in the working group. So that's not completely clear to me, but maybe you have to talk with Alex on that.
Okay.
So there is a section that is called IPv6 link.
Mm-hmm.
I have to read it,
Mm-hmm.
and maybe we can discuss about this section, whether we can include it in the main deliverable or no.
Okay.
Okay, I need to see it.
Okay.
I need to read it.
Okay, sure. Yeah. Okay, go ahead.
Rahul Jadhav, Huawei.
Mhm.
So the third point mentioned here, the support of ND proxy. This
Okay.
work is currently pursued in 6LO,
Mhm.
6775 update. So maybe you want to have a look at that.
Okay, so 6 law.
6LO, yeah.
Okay, they also working the neighbor discovery.
Yeah, it's the neighbor discovery, the proxy operations. wherein
Okay, I see.
It's exactly the same.
Okay, thank you. Yes.
There's an extended ARO option,
Mm.
which is explicitly for this purpose.
Okay,
Just
sure.
wanted to
Okay,
know.
thank you. Yeah. So no question. We can moving out the next document. I think this problem statement is very important document for our working group, because according to this statement, our next step will be decided. So, okay, next slide, please. This is a problem statement. So recently, this draft adopted as a working group draft from the merging the Alex, the V2V draft, and the V2I draft. Next slide. The objective of this document is to specify the problem statement for the IP version 6 based V2I and V2V networking. So the assumptions are similar to previous the survey. The focus of this document is, and now we focus on networking issue in one-hop IP communications, not multi-hop. However, internetworking between internal network of cars over RSU are considered. Next slide. This figure shows vehicle network configuration. So we have the vehicles, and the vehicle can talk to RSU using V2I, one-hop IP communication. Also, vehicle can talk to using V2V, one-hop communication. And also the RSU connected to the internet. Also, traffic control center is for the central load or manage the vehicle information, such as the trajectory. Next slide, please. So this next slide figure shows the each vehicle or vehicle and roadside unit has its own network. Remember, nowadays BMW manufacturer automotive, they try to replace the CAN network with the Ethernet. which means the internal vehicle network will be replaced the Ethernet, so we can have a multi-subnet environment. So this one is the edge router. So edge router providing external. So this link will be the OCB mode mainly. Probably other link can be used. So they can talk to each other fast. Remember, the vehicle passing through intersection over load segment. So the speed is very important. So the setup this link should be fast. Next slide. The secondly, this one is a vehicle-to-vehicle communications. So the vehicle-vehicle communication case, we can consider one scenario is the host 2, we can say this is some navigator, this also navigator. So they try to exchange information context. So we provide some context-aware navigation system, avoid accident. Also, the vehicle 2 may be the pedestrian, so they can exchange information, vehicle driver recognize pedestrian existence, and then avoid accident. Next slide, please. So the issues for the IP version 6 vehicle networking, first one is the addressing issue. So the V2I case, we can consider the policy of addressing local, global. So local case, we can consider the dedicated local isolated addressing can be used. Otherwise, to provide some internet services, we need to consider global IP. So also the parsing for global IP case, we can consider some 3 scenarios, which means the multiple RSU cards for the multi-link subnet, which means they can construct extended subnet. The secondly, the per RSU, they provide the individual subnet. The third one is the neighboring vehicle can construct the link, the single subnet. Next slide, please. So secondly, this one is the V2V addressing issue. So V2V case address configuration can pre-configured or dynamically configured, okay, using the neighboring discovery or DHCP. Some vehicle performs some master DHCP server, something like that, allocate. The secondly, communication path setup problem. So the question is how to establish IP communication path between the computer in one vehicle. Remember, the vehicle has internal network, okay? Third one is the discovery of exchange server problem, which means that the discovery of server problem means the edge router should recognize quickly neighbor the edge router. And secondly, the prefix exchange should be done to communicate each other. Next slide, please. So the adaptation of discovery, some gentlemen mentioned, we can refer to 6 row maybe. And secondly, the address auto compilation. So we need to consider for adapted version for vehicle network. Next slide, please. Naming service. So recently, the 6-man or 6 ops, they discussed a lot about naming host name DNS configuration. So based RA or the DHCP, something like that. So looks like the many people prefer to the simple implementation. As long as I understand, I think RA-based is the simple approach. And secondly, the DNS name auto-compilation. So this is related to the service discovery. So remember, the one vehicle has many equipment, ECU or some other equipment within vehicle. So in that case, manual configure for the vehicle equipment, especially domain name, is a very hazard or discomfort, right? So we try to providing a configuration approach. Okay, so the first approach is the DNSNA. This is my the individual draft, and second one is the multicast DNS. Okay, they providing the auto configure approach. Also, using DNS dynamic update, we can register the DNS name to the authoritative the DNS server. Next slide, please. the mobility support for V2I, so we can think of the DMM approach or traditional mobile IP or proxy mobile IP, host-based, network-based, or the DMM-based. So also we can consider the high-speed vehicles. So in the past, the mobile IP case, here Charlie Perkins is the expert. He's the inventor of mobile IP, right? So probably he can provide some good direction for these issues. Next slide for that. Next slide. And the service discovery case, I mentioned the vehicle learning some cooperative, adaptive cruise control, also context-aware navigation system, something like that. In that case, that kind of service should be exchanged. So we need to think of how to provide efficient service discovery. So the first one is multicast DNS-based approach, DNS-SD. Second one is, this is my personal proposal, extended neighbor discovery approach. Next slide, please. So this one is my proposal. So the services are registered into internal some database, such as a DNS server, authoritative DNS server within vehicle, and then that information advertised to neighbor vehicle. Next slide, and then they can exchange the message. Next slide, please. So you can see left-hand side, this is a vehicle, this vehicle. They exchange the service information using the vehicular extended neighbor discovery message. The idea is neighbor discovery message having prefix information within internal network and also service from the authoritative local DNS server. They encapsulated by the neighbor discovery message. They can quickly recognize neighbor one. So appendix, I explained in detail. You can refer to the appendix. Next slide, please. So security is very important. Authentication and access control. So I think the three and I discussed about this one. So the vehicle case, first of all, we need to trust each other, such as location, driving, speed, something like that. So the question is how to provide the fast or reliable some authentication method for vehicle network. Next slide, please. And also we can using periodic change of MAC address and the IP address and try to prevent the tracking of the vehicle. So we can consider privacy support. Next slide, please. Also, three.
Sure, so how is the MAC address exposed in what scenario?
Exposed?
Is the MAC address of is it exposed to the outside network? I'm not clear on the MAC address.
Oh, MAC address. So probably pseudo MAC address, not actual MAC address. Okay. So probably to avoid actual MAC address, pseudonym is used to try to avoid the actual MAC address.
We'll take it off. Okay, thanks.
Okay, Alex.
To answer, this is Alex Petrescu. To answer the question of how is the MAC address exposed, well, there are many IP messages that include MAC addresses, especially neighbor solicitation, neighbor advertisement, router solicitation, router advertisement, and they are really over the air between two cars or between a car and the roadside unit. So basically, anybody along the road with a laptop could just listen and hear all these IP packets and all these MAC addresses.
Right.
Okay, so they are exposed.
Right. Okay, next slide, please. Oh, okay, Sel.
Yeah, just to know that Sel John from Sungkyunkwan University. In the mobility page is that just to know that when it comes to vehicles, it only concern about vehicles only or the user inside the vehicle. You also care or not?
The users?
Yeah. When you say the vehicular networking
here,
you're talking about vehicular mobility, just the vehicles only, single vehicles, or you care also users inside vehicles as well.
Okay. So I think that's a very good question. So inside internal network, right? So not necessarily it is wired. So wireless also considered, right? So users, a smartphone, maybe the mobile device connected to internal Wi-Fi. So in that case, we can say.
Because that the page is that when you talk about the issues in mobility management, if you take into consideration users inside the vehicle, I mean, I hope that the issue need to be more specified, because that a mobile IP already have its own that network mobility solution,
Right, exactly,
Nemo
yeah.
BSP, and PMIP also has a prefix delegation
Right.
for user inside. I mean, if we have any more issue based on that former these RFCs, that maybe I think that will be specified. All right.
Okay.
Just one quick comment, right? So from the service point of view, the identity of the car is truly about the egress device, right? Shrigandavel. Yeah.
Okay.
Sorry. Yeah. So the inside devices, there's no security relation, or like whoever is providing mobility for the devices, they don't have security relation with the inside nodes. It's
Right.
only the head unit which has the security service relation.
Okay. Okay. Many issues, right? Progress.
No. I just want to get clarification. Nancy Cam Widget, Cisco. So I'm trying to understand and follow all this. I did provide feedback in the 1609 that rotating MAC addresses doesn't really solve privacy. Okay. So I would question why we believe rotating IP MAC addresses may provide privacy. But to the question of the messaging that's here, I think we need to be very careful in saying head unit, right? Because that has connotation. So I think from my purposes in this group, we should think about it as a car conversing with another car, and not speak of it in terms of, is it a head unit, because architecturally, that head unit may be instantiated differently in one type of car versus another. Yeah, and then to the comment of the users, I'm not sure how a human user would come into play. Again, from the conversations of what we're referring to here being a vehicle to another vehicle or a vehicle to an infrastructure, those aren't human. I think of them as a car.
Okay. Nancy, to respond to one thing you just said, the way I interpreted this was that if we didn't change the IP address at the same time we changed the MAC address, then any incremental privacy we're getting by changing the MAC address will be lost. That's how I took it.
So Nancy, Suresh Krishnan, so are you saying this is not needed, or like I'm trying to understand like what you're going for? Like, so I think the point, like, okay, adding to Russ's point, right? Like, so there's a human associated with the car who can be tracked by the car. So that's why like it's important in this case, right? So it's not the tracking of the car itself we're worried per se, but like a human associated with the car, right? You can make a connection between a human and a car at some point, and then car and something else at that point. So this thing will like break that link. That was the idea.
So is an IP address tied to a human? Because a car is assigned an IP address. You might have different humans driving that car. That's my point. Thank you.
Yeah.
Right. So I'll give you my own personal example, right? I own too many cars. I have 5 cars. I have 4 drivers. But at any one point, one particular car is assigned 4 drivers.
Okay.
That's my point.
Okay.
Small search.
So
Yeah, but I mean, and I'm presuming that this isn't just a consumer car, but if you think about a public transport car, or if you look at the trends of...
you don't use Uber with.
Okay, no. Okay, rental cars, how about that? Okay. So my point, anyway, I won't reiterate it. I think you understand my point.
Okay. So can you send some text suggestions to the authors, Nancy? Thank you.
Sing.
Okay, go ahead. Yeah.
I just have one very quick remark on the. My name is Friedemann. Sorry. On the last slide, slide 15, you said that you could use the VIN
Next slide.
as
Previous one. Previous slide, right?
Yeah, right. That you could use this as authentication mechanism. I just wanted to add that in at least the topology of cars I know, there you just get it via the CAN, so it's not authenticated. You can spoof it easily.
Right.
There is another one that is learned usually in some, I don't know, the component protection system. So it would be really important to somehow specify that this one really has to be an authenticated one, because if you take, if the head unit takes it from the CAN, it's not worth anything. I mean, you can spoof it.
Right.
Yeah.
So probably we can come up with some one-time password or so, something like that. Try to finish like a basic the ID. Okay.
Yeah, but authentication is a really important issue. I mean, how can you make sure that it's I mean, especially if someone is messing with a CAN network. I mean, very often it's assumed that if the CAN network, I mean, very often the OEMs say, okay, if someone has access to the CAN network, everything is over anyway, because nothing is authenticated. I mean, maybe some diagnosis stuff, but if we are using this for such external networks, this is really important.
So right now, automotive, the company, they consider the ECM control network should be a kind of blocked outside, because they prevented the accident. So probably entertainment or some navigation case, it's not closely related to the mechanics movement. So probably we can focus on that, I think. Okay. Or the driving case, probably very dangerous, I think. Right. So because academic
my point
is already
was just, where do you get this information from?
Okay.
I mean, if you have some kind of EC.
Okay. So Alex can address something.
I can answer. The VIN, you can get it from the CAN, and please secure the CAN if you can. And you can also get it with a camera by taking a picture of the VIN that is printed on some shields. Okay. And that would be more secure, but you could also hack the camera, so please protect the camera.
Okay.
So I just had a comment on tracking MAC addresses.
Okay.
I'm Dino.
Previous one. Yeah.
Nice to meet you.
Okay.
I think we shouldn't worry about tracking MAC addresses. They're relatively opaque addresses, and you can't associate with them human because there's too many humans driving the car, as that example. I think what we should worry about is DOS attacking the MAC address, and what the roadside units are doing to keep the channel open, a communication channel open to the MAC addresses, so it can do real things.
Okay.
Brian Wise, Cisco. So if you want to be worried about privacy MAC addresses, IEEE 802 has a privacy document that's being worked on right now. I didn't see referenced. If you're interested in referencing it.
Okay, so could you send the reference to email list?
Yeah.
Okay, thank you. Okay.
And the answer is that it takes a lot more than changing your MAC address to have privacy.
Okay. Okay, thank you. Next slide. So the confidential data exchange, we can using the IPsec somehow. So the ESP and the IKE button for the key exchange management. So we needed to consider this one. Probably this is one of the candidates. Next slide, please. So next step is we try to improve our content with the mailing list discussion, and also try to take a more text from the Alex, the draft for B2B. And also we needed to synchronize with the other standardization documents, such as, for example, the Alex, the OCB, and the ISO and FCC, the FHWAK, for example, RSU, RSE, the definition are different. So we needed to clarify which definition is for our working group. And also we welcome to your comment, and then we moving forward. Thank you. Okay. Any questions, comments?
Yes, I have a couple of questions. One is, this document is supposed to be a problem statement, but from a quick look, there are some sections that seem to me more like a survey kind of thing, like IP mobility. This can be solved with this, this, and this. So is there any problem to solve? Because if none, maybe, I mean, shouldn't be a section on the problem statement.
Okay.
Just, I mean, one example, not take IP mobility, but so I think that we need to take care of or take a look at that. Another comment I have is that I think that the sections are maybe, I mean, we are trying to cover many things, but the level of detail we are covering those, to me, seem not to be enough. Because, for example, one critical part is the authentication, the privacy and the security. This is one of the key content that is supposed to be in this document, and it's just half a page of the whole thing.
Okay, sure, yeah.
And we have got a lot of discussion on this, so I think that deserves more attention, specifically that.
Yeah. Mm-hmm.
And I think we need to work more into that specific issue.
Okay.
So,
okay, that's great. Okay.
I have a question for Brian Weiss. If your MAC IP addresses are rotating, will ESP work?
Would ESP work? You're asking about IPsec ESP?
Yeah.
Well, it's a art problem, isn't it?
But the point is that Ike sets up an exchange between two IP endpoints.
Right.
And if the name of that IP endpoint keeps rotating.
Oh, if the IP address changes.
Yes.
Oh, I thought you said MAC address. Sorry.
MAC and IP
MAC
address.
and IP at the same time. Oh, I think that's probably a complication. Now there is I think, yeah, Mobike has a way of, I think, of telling your peer you're changing your MAC address.
Right.
Your IP address.
So I think that section is incomplete, is my point, or where I was going. This
Sri might have.
I just wanted to make sure you guys hadn't done something to accommodate that since I stopped paying attention.
Sri would have details.
Okay, so could you please review that section? Thank you.
Okay. Thank you. Yeah.
So we need reviewers, as we mentioned at the beginning. So please, we will not be able to move forward without reviews of the document.
Mike? Oh, you're volunteering.
Thanks, Michelle.
Back there too. Which we agreed. Okay, that was the last agenda item. So if there's any other business? Going once? Going twice? Have a good evening and enjoy Bits and Bytes tonight.
And if somebody has not signed the blue sheets, come forward, please.
So he goes, oh, never mind.
Well, you didn't get to.